All right, a lot of people have asked how to hook these Lynx Joule lamps up, what kind of bulbs to use. Some people have had problems with certain kind of bulbs, so I'm going to go through some of the do's and don'ts. First off, your battery. Make sure you understand where positive and negative are. This particular battery, I just used a multimeter on it to check. But mark your battery. The convention is red positive, black negative, and that's the way I've set these Lynx Joule lamps up. Black is negative, red is positive. If you reverse it, you will burn out the transistor. I thought about putting a diode in line with the positive, but it would need to be a large diode to handle the power, and there's some voltage drop. So I'm going to rely on you to get the hookup right. And the next thing is, there are a variety of LED bulbs. This is a Philips. It's non-dimmable, and it's a 3-watt bulb. You'd think, oh, no problem. This is going to kill the LJL. The reason is the bias back to the transistor's battery voltage. And there's only 3 ohms of resistance in the secondary coil. So you're really throwing way too much voltage and amperage back to that base of the transistor, and it will harm it. So you want to avoid, hate to say it, but I would avoid Philips and Lights of America, especially non-dimmables. These are really hard to find now. This is a Philips. It's actually dimmable, but something about the circuitry in this bulb is also very hard on the LJL. So I'm using Utilitech, or these are really nice, these Ecosmart bulbs. These are 6-watt. These put out really nice light. Very easy on the LJL. So those are nice. Lowe's, Home Depot, Amazon carry those types of bulbs. You can usually get them for around $9 to $10. So that's what I would recommend. Okay, I'm going to risk it. I've got this one Philips bulb. It's a 3-watt bulb. This should pull maybe 150 milliamps. I could very likely burn this transistor out with this type of bulb. Not a good bulb to use. We're going to turn it on for a second and watch the amp meter. I'm not going to spend a lot of time with this bulb on because it's a transistor killer. Alright, we're running 6 watts on a 3-watt bulb. It's not a great bulb for this system. Let me show you what this bulb will do. This is pretty interesting. If we take this bulb and any coil of wire, this is just a spool of wire, okay? We'll take the LJL out of this completely, and we're going to hook. It doesn't even matter which input you put where. It's going to go through a coil of wire, 12-volt bulb, and light this bulb. Okay. These bulbs will run off any inductor, any coil of wire, just a spool of magnet wire, whatever. So they're kind of weird bulbs. There's another type of Philips bulb. This one, little Candelabra. It's supposed to be 3-watt. Let me show you what it does on the LJL. Alright, so here's this little Philips 3-watt Candelabra bulb. It's pulling an amp. No good. Not good for our transistor. That's 13 watts on a 3-watt bulb. So we're not going to run this one on our system. Let's look at a fluorescent. Fluorescents are special because they're amperage driven. Got to heat up the gas to make continuity from electrode to electrode through that. It's basically a neon tube almost. So we're going to draw a lot more power just because we've got to heat that tube. Once it heats up, the power drops a little bit. Get that in view so you can see it. Zoom out a little bit, okay. Turn the light off so you can really see what's going on. Alright, fluorescent. We're drawing 1.4, so about 16 to 20 watts. and it will start to warm up. It's going to draw some amperage. This won't kill the transistor, it's just not the most efficient type of bulb. And it's pretty bright. So it's at 14.6. 13.8. Okay, it's getting warm. So we're losing some power just because it's getting warm. But you can drive these with the LJL. Transistor is not even warm. So we're okay, we're not hurting the transistor. But these systems are not really designed for a whole bunch of fluorescents. I would say max you could run on LJL would be 3, and that might be pushing it. But you probably could do it. So really, yeah, any Utilitech, Ecosmart, you could experiment around, but I'd try and find one on sale for $9, $10 if you can. Amazon has them on sale sometimes. But that's really what the system's designed for. Quite bright. I mean, real nice. Transistor's not going to run hot. You can plug in a ton. I mean, I haven't found the limit. There's just 4. I've had 12. I've only bought 12 of these bulbs, and I've had 12 on the system, and it pulls about maybe 3 amps. So I mean, it's a pretty nice little way to go. So we're pulling an amp right now. That's 13 watts. So this times voltage. And if we took a voltmeter right now to the battery, voltage would have dropped a little from that initial 1355. It's probably down to 1289. So we're close to 13 watts. Anyway, I hope this helps. That's how all these work. Oh, one other thing I wanted to show you. On these coils, if you want to tinker down here, this red wire comes right in at the bottom of this primary. If you want to mess around, you can bypass the red wire, make a little hole, say on the back here, LJ, make a little hole somewhere, and just put your positive in here. What will happen is you'll drive the voltage higher, and you can actually run your bulbs brighter. I have these set up, kind of a happy medium, somewhere between fully bright and dim. If you want to go really fully bright, tap in, maybe 1.5 inches up from the bottom, fully bright. So that's how this works. Oh, another thing I wanted to show you is the screws for the transistor are right there. Take a slotted screwdriver. You can unscrew those two just lightly. Just loosen them. Take these 2 screws out. You can pull that transistor out and replace it. I haven't had to replace one transistor. Initially when I was experimenting, I burned a lot up, but since I've made these, I haven't burned one up. So I did make it so you can pull them out. Do take note of where the base connection is to the small magnet wire that's going into the secondary. The negative's got to go to the emitter. If you look on the package, you'll see which is the emitter, which is the base. You want to make sure those are set up correct. Alright, well that's it. Thanks.